Okay, and we're back online. So thank you so much for joining us for the almost last session. So it's going to be like the second last session of the day after, I don't know, 10 or whatever number. I already lost the count. It's been like a long day. But my days become a little more joyful because I have here with me my good friend Mark. Hey, Mark, how's it going?
Very well. How are you?
I am okay, just tired.
Yeah, I understand. Yeah, but it's JNation. How can you not be excited, right?
Yeah, definitely. Yeah, I mean, I've been telling this to everyone that's joining that we will definitely love to have all of you here in Portugal. Unfortunately, that's not possible right now. Maybe next year we can make it possible. Let's see. So yes, so Mark's gonna talk to us about spring. Is that correct?
Yes. Yeah, and
Uh,
several aspects of it. So
yeah. Are you okay to talk about spring right now?
yeah, yeah, I think so. I think that's fine, probably.
Okay. Just a little joke. Maybe people didn't understand, but that's fine. Uh, anyway, if anyone in the audience wants to send questions to Mark, feel free to relay them back to me over Slack or YouTube chat, and I'll happily put them back to Mark. Um, yeah, so Mark, without any further delay, I know that you have a lot of things to show, so please feel free to start. And good
You
luck.
know me. You know me too well, my friend.
Yeah.
Okay. Well, I will. Let me see if I can get this screen shared without any major mishaps. So let's find out. Oh, that looks good, right? You can see that.
Yes, definitely.
There we go. Okay. So yeah, what Roberto was saying is that yeah, I'm no longer on the Spring team. I'm no longer at VMware, but I made a small change in my situation. But I'm still working a lot with Spring. I'm still very excited about the Spring ecosystem, and I get to talk about it still. Nobody's told me I can't, so I guess it's okay. So welcome to this evening, I guess for you session, Spring Boot Omakase. It's early afternoon for me. And this is a chance for me to kind of share anything that I can or want to about Spring Boot that I think is cool. An omakase is a Japanese term for a chef's choice. So a lot of times, if you go to a restaurant, if you like food as much as I do, you may go to a restaurant and you either don't know what you want or you just think, let's let the chef choose. And the chef gets to choose either some favorite items that he prepares that people or she prepares and people request and enjoy, or maybe it's just something that chef likes to try out, wants to try out on a new audience. It can be any number of things, but it's typically things that are, maybe just something that chef is proud of. And that's what I want to basically share today is just some things that I find very interesting, very exciting about Spring Boot at this point in time, which changes from time to time, right? Because there are so many cool things about it. But anyway, that's what we're in for today, as I call it, my scalability and deployability edition, although there are a couple other things thrown in there as well. I'm going to have to move pretty quickly because, well, there's a lot of stuff and not a lot of time. Oops. You know who's talking to me. Okay. So my name is Mark Heckler. I actually used to work with Spring at VMware, but I recently made a change over to Microsoft. I'm very grateful that have me, but I am a cloud advocate for Java and JVM languages at Microsoft. So if you think of something after the fact that you want to ask me, this invariably happens to me when I hear something. I think, oh, I need to ask that question, and I forget it, or I don't think of the question until 5 minutes after I leave the room. That's fine. If you think of it during the session, please do send them to Roberto. If you don't, that's cool. Reach out to me. Email works. There are a couple email addresses there, but Twitter is the best way. So if you have a question and you want to post it or comment or feedback or whatever, post it on Twitter. Or if you want to maybe ask me a question or make a comment that you don't want to share with the entire world, the Twitterverse, send me a direct message. My DMs are open at mkheck. So anyway. Oh, yeah, I must be off to a great start. Okay, so who am I? Again, I'm an advocate for Java and JVM languages at Microsoft. I'm also an author. I have co-authored a couple of books. I have contributed content and code to several other books, and I've even done something else in 2020 that I said I would never do, which is solo author a book, which I'll get into momentarily. I am an architect and developer by trade, and as you might surmise from the next couple points where most of my expertise has been won, it's been in the JVM ecosystem, as well as what I'm doing now, right? I am a Java champion, a Java 1 rockstar, a groundbreaker ambassador, a developer expert in Kotlin. So I love the JVM. I love Java and related languages. It's just a great place to be. I'm also a licensed pilot. People ask me, what do you do in your spare time? And then my first response is, what spare time? But atop that, I actually have always loved flying, and I am a licensed pilot. I don't fly big airplanes, just small ones, and I like it that way. So I can't necessarily fly to Europe myself in my plane, but someday maybe, who knows. But yeah, so I like to fly around and see things from several thousand feet up. That's kind of a different perspective. So again, new book. This is it's been out maybe 3 months now, 2-3 months. But yeah, 2020 was a momentous year for several reasons. One of which is, again, I did something I said I would never do, which is solo author a book. Because I just felt like, I maybe could add a different perspective. Again, perspectives are a thing for me, and I think all of us. But I just felt that it was something I could maybe plug some gaps that I saw, or that people would ask me questions. And I thought, maybe that would be a different way to cover it. So if you're interested in checking it out, please do. It's at all of your favorite booksellers, or if you have an O'Reilly Safari Books Online subscription, you can get access to it. Or if you just want to peek into it, you can follow the link above, and you can follow that to O'Reilly's site and get a sample membership for a week, 2 weeks, and just check it out. Or you can just follow it on Twitter and see when the book tweets. Okay, so today, I love this quote by Leonard Bernstein, famous composer and conductor of the New York Symphony. He once said, "To achieve great things, two things are needed: a plan and not quite enough time." And I think we have both of those today: a plan and never enough time. So I'm going to roll right on in. So the plan for today, just for the brief time that we're together, and by the way, that's the thing about these sessions, is they have a decent amount of time, but when it's compared to all the time afterward, it's minuscule, right? So I'm going to try to cover some highlights, some introductions, kind of get you thinking along some paths, and show you some things that I'm pretty excited about. But it's just the start. It's starting to pull that thread. And if you think of more things later, or questions, or again, you want to explore different ways of doing things, that's great, because we have much, much, much more time after the fact than we do here together right now. But we're going to be talking about, and I'm going to be coding some applications using Project Reactor. And Project Reactor is a reactive streams implementation. Now, why reactive streams? If you are developing Java applications, Spring Boot applications, and they're blocking, right? They're imperative Java applications, and you're not having scalability issues, you're fine. You're fine. However, there are many times that we run into issues in terms of scalability, in terms of low resource utilization, not efficient resource utilization. And what I mean by that is that in many cases, I guess I should back up and talk about how reactive streams kind of came into being. What is its reason for being in the first place? And what a lot of very intelligent people got together and decided and realized is that when you're talking about interactions between applications, that's really where the bottlenecks typically occur. And sometimes folks look at this and kind of mistakenly as a microservices only problem. However, even with monoliths, most monoliths aren't an island, right? They will reach out to other external systems and APIs, and they will query and interact with them in order to provide that complete set of data and capabilities to the end user. So even a monolith is not an island. So and if you look at microservices, you consider even more interactions. And for each of those interactions, you have a potential of a very big bottleneck. And what I mean by that is that if you have, let's say, 100 consuming services that are pinging a backing service, a producing service for some kind of a response, they're asking for some kind of a calculation or a retrieval of some kind, then if you have, typically for each request, a service will spin up a thread to service that request. And up to that 100, let's say you have 100 threads, you have 100 requests coming in, everything's fine. Performance may be brilliant. But what happens when that 101st request comes in? What happens when the 110th or 150th or 500th request comes in? So you go from, in many cases, in a blocking set of interactions, from very good performance to very terrible performance, at least potentially so. And with reactive streams, you insert an ability to have an event loop to process those and to more fully utilize the resources in that producing service. Now, a lot of times when I get to this point, and I apologize for being very brief with this and kind of giving that high level gloss over description, happy to discuss this more at length later. But at this point, a lot of people say, well, that sounds a lot like asynchronous interactions, right? And to some degree, that's true, because with an asynchronous interaction, it is more efficient. So if you have a consuming service that is making a request, it can go on and continue operating and not just wait, not just stop and wait for that request or response to come back. But what can happen with an asynchronous set of interactions is that it does nothing in terms of flow control. So for a requester, that consuming service, if it says, give me all of the locations within a 100-mile radius, that's fine, or 200-kilometer radius or whatever. When it gets a response back, it may be overwhelmed just by the sheer number of data points that come back to it. And there's no real way. Asynchronous handles some of the processing, but it doesn't handle any of the flow. So with reactive streams implementation, of course, you have in nearly all cases an asynchronous element, but you also have the ability to provide back pressure. So that consuming service, instead of saying, give me everything you have within X amount of distance, what it will say is, give me what you have within X amount of distance, but you only give me the first 10 values or 50 or 100. Because what you may have is a client application on a cell phone that is over a very low bandwidth connection. And if you try to send back hundreds of thousands of responses, or records, I should say, in a response, that can quickly overwhelm that less capable or less performant consuming service. So with reactive streams, you have both. You have asynchronicity, you have back pressure, you have several other features that make it very nice in terms of increasing that system-wide scalability. RSocket builds on top of that. So RSocket will actually increase scalability. It adds resilience, so you can have resumability if you change connections, let's say from that cell connection to a Wi-Fi connection. It also gives you the ability to use different protocols underneath transparently. It also gives you the ability to extend from a request response mode or some workaround thereof, which basically most things that we do are workarounds if we need to do something different, to different interaction models that are very extensible and very extensive, I should say. That give you a lot more flexibility as well. I'll show you those as we go. I want to also show you Actuator for providing production-ready insights and analysis. And then I want to talk about deployments, containers, some native code, and what have you. And again, time is going to be our enemy on this one today, but hopefully we'll get through at least a good chunk of this. So let's code. Let's get to the good stuff. Pardon me. All right, this is our friend Maurice Moss, and he's ready to go. So why shouldn't we be? All right, so let's go to our favorite place here for getting started building Spring Boot based applications, which is the Spring Initializer, sometimes referred to by its URL, start.spring.io. Now, you don't have to create Spring Boot based services or applications using the Spring Initializer, the website itself. Now, you can actually write them by hand, custom bespoke artisanal code. However, it's not the best use of your time. Don't really recommend it, but you can. You can also curl this or HTTP this or access this via an IDE. However, they all go to the same place and they all produce the same deployable or the same artifact that you get back. So if your friend or colleague likes to use the command line, that's great. If you like to go here, that's great. It's all the same. So it's a consistency, which is absolutely essential. So let's get started. I'm going to just create a couple of services that will allow us to interact. Now, I should say with RSocket, one of the other things that is incredibly powerful about it is that in most cases, and I kind of alluded to this earlier, in most cases with the old request response or long polling and things like that, you have the requirement that you issue a request to get a response. So it's a very, very much client-driven, if you will, set of interactions. With RSocket, once an initial connection is made, now obviously you have to have one service that will sit and listen for requests, and then another service or services that will make those connection requests, to come in and then establish the connection. But once that connection is made, they're effectively peers. So any distinction between the two disappears. No pun intended. So at that point, you can have a meaningful conversation or even a meaningful dialogue or monologue between multiple services, which is super powerful. And I'm sure once you start seeing this, you'll see various different use cases that it opens up to you that simply aren't there in many other ways. So again, let's get started. I'm going to use Maven as a build system in Java, but again, you have choices here. I'm going to use a current version of Spring Boot, which is 2.5.1. I'm going to change the group to the Hecklers because I can, thehecklers.com. I'm going to, since this isn't, I mean, it starts off as a client and as a server, an RSocket server, an RSocket client, but they don't last that way long and then they're peers. So I'm just going to call these thing 1 and thing 2. I'm going to use the current version of Java, the current production version, long-term support version, which is 11, the current packaging, which is WAR, and then I'm going to add a few dependencies. So the first thing I want to do is Reactive Web. I want to bring in the Spring Reactive Web dependency, which again gets us WebFlux built on Reactor and Netty. And then I'm going to also include RSocket, of course. I'm going to bring in Lombok because I'm a lazy developer, lazy good, not lazy bad. It just helps me make, when I'm using Java, use less boilerplate, create less boilerplate. Again, I want to show you some Actuator capabilities. And then, of course, native, Spring Native, which this is, again, still experimental, but very, very robust even now. So that's kind of cool. All right, I'm going to generate the code. And yep, I'm just going to drop that on the desktop. And then I want to go back and just in the interest of time, I'm going to create thing 2. So we have thing 1, thing 2. Any Dr. Seuss fans here? All right, well, maybe not. Okay, so let's see. And that's interesting. Why did that come up over there? Gotta love the Mac. Mac keeps me hopping sometimes. I just got a new machine, so I'm still configuring it. So once in a while, things that normally would work don't, just because I haven't yet configured them, but such is life. All right, so let's unzip thing 2 project. And we'll open that up also. And I have these side by side so we can see them. And let's see if we've got enough space here. So let's go to our application properties. Yep, that looks pretty good in terms of size. And yeah, so hopefully we can see that. And then we'll close this out. Application properties and app. Okay, now before I get started, I do want to show what I'm working with in the back end. Now, again, I'm a pilot. I love aircraft. I love seeing, learning, doing with aircraft, anything basically. Each aircraft in the U.S. and most other places, I believe, have what they call transponders. They have what they call ADS-B here, ADS-B out, which is automatic. Let's see, automatic dependent surveillance broadcast out. So it's just a way that an aircraft will broadcast its position, a position report each minute, and just let air traffic control and the control centers know where that is so they can deconflict and make sure that planes don't fly into other planes, which is generally a very good thing, right? So I actually have a box and an antenna that lets me tap into that as well, which is kind of cool, right? So anything within a small radius of my house, I can pick up. So that's, semi-interesting. So it provides quite a lot of information, like a call sign, the aircraft call sign, the squawk code, which is the transponder code for unique identification. The aircraft registration number, the flight number, if it's a commercial flight like Delta Airlines or Southwest or United or Lufthansa or what have you, the route that it's flying. So JFK Airport in New York City to LAX, for instance, the type of aircraft, the category. You'll see things like the altitude of the aircraft, the current altitude, and then selected altitude, the altitude that's targeted. So if it's currently is just taken off and it's at 5,000 feet, but it's heading to 30,000 feet, it'll show both of those in these two fields, the heading, the airspeed, the vertical rate, the rate of climb and descent, and so many other things, position, the latitude and longitude. So a lot of interesting stuff here. I actually have a couple of endpoints defined, and one is just your standard reactive streams endpoint with Project Reactor. I should say with reactive streams, for instance, you have 4 interfaces, and they're just interfaces, so you can have different implementations that define them, and then you can verify how interoperable, say that 3 times fast, they are with the test suite, of course. But a flux is reactor speak for a publisher that produces 0 to n values. So with reactive streams, you have a publisher, which is the thing that produces values, a subscriber, which is the thing that consumes values, a subscription, which is the contract entered into between the two, and then a processor, which actually incorporates both subscriber and publisher, because it will subscribe, receive values, manipulate them, and then pass them on and publish them to its subscribers. So a flux is a publisher, a kind of publisher, 0 to n. And if you think of this in terms of, let's say, return values in this case, you might return either a single value in typical blocking imperative Java, like an aircraft, or you might return an iterable of aircraft, right? Some kind of a collection, of sorts. So in this case, a flux is like a reactive collection, a reactive iterable. And then you can return a mono, which is Project Reactor's type to return 0 or 1 or for 0 or 1 value. So this allows you to be more specific and to still maintain that reactive endpoint. We also have here an RSocket endpoint, and we've mapped that to AC stream because it does produce a stream. And once again, it's a stream of a flux of aircraft, but it does so over an RSocket connection. So this is running. We're up and running here, and we're ready to start from there. So let's see. All right, I'm going to start with thing 2. And again, for a domain, I'm going to use Lombok to create a data class, and we'll call this class aircraft. And I'm just going to get a subset of data because that's all I really care about. And I actually should do a JSON ignore properties, ignore unknown true. So I want to grab a few key bits of information like the call sign, the registration number, the flight number, and the type. And then I want to bring in, I want to have data values. I want to have member variables for things like the altitude, the heading, and the airspeed, right? And then I also want to make sure we track the position, so latitude and longitude. Now I'm just going to, again, in the interest of time, I don't really like doing this ordinarily, but situations sometimes dictate. So there we go. Now we have our domain established. Now, on our RSocket server, I guess I should double back and do one thing before I forget it, which is define the server port, because Spring Boot applications, as you saw, default to 8080. Well, we're going to have multiples running, so we don't want to have a port conflict. That's usually a bad thing. So I'm also going to define my RSocket server port, and we'll say that's 9091. And that's enough to get us going. That between the dependency on the class path for RSocket and defining an RSocket server port is enough for Spring Boot's auto configuration to determine that yes, indeed, we do want to configure this as an RSocket server. So I'm going to create a controller class here. There we go. And we'll call this class, cleverly enough, thing2 controller. And I'm just going to come back to that here in a minute. I want to go back to my client class, or my client application. And just by having RSocket on the class path, what we have injected, Spring Boot's auto configuration will inject an RSocket request builder. So RSocket requester.builder. And we're going to take that builder and we're going to use the builder to create a connection over TCP. And TCP is one of the two transport protocols that are supported within Spring Boot's implementation of RSocket or use of RSocket. There are more, but I feel like this is the easiest, most powerful way to consume RSocket or use RSocket, leverage it in applications. So I'm going to point this to localhost, and we're going to, again, go to 9091, which is the port that we defined here as our RSocket server. So there we go. And now we can use that in our application. So I'm going to create a component here. We'll call this our thing1 component. And I want to inject our RSocket requester so we can use it here. Now, I can use field injection, not a good idea, but I can. I can use constructor injection. I like to, since I'm using Lombok anyway, let Lombok create my constructor for me. So it will create a constructor with a parameter for each of my member variables. In this case, we literally have one. So it will create my constructor for me, and life goes merrily along. So with that, I'm going to just do a post construct method, and we're going to just create a method here that we can leverage to test out our endpoints. Now, to go ahead and let's go ahead and create those, shall we? So there are 4 interaction models, as I mentioned before. In RSocket, we have request, response, which you might expect. We're used to that, right? But we also have a more powerful request stream, meaning that with a request response, you can get back a response with one or multiple values. But with a request stream, you may get values over who knows, maybe an indeterminate amount of time, but the values just keep trickling in. And that's legit. That's a valid interaction model using RSocket and, of course, Reactor underneath. We also have the fire and forget model, which is powerful enough because in many cases, we want to send a value, but we don't care. We don't want a response. We don't need or care about a response. So that allows us to do exactly that. And then really cool, we also have a bi-directional channel, which, as you might imagine, it gets where things get really interesting. Now, I'm going to, since I'm going to be using an RSocket connection upstream from this to my Plane Finder application, I'm going to do the same thing here. I'm just going to use the RSocket requester builder to build a connection there and return builder.tcp. And we're going to, now in this case, because of something I'm going to be doing down the road, I'm not just going to plug in localhost. I'm just going to plug in the IP address for localhost. And you'll see why here momentarily. And then upstream, it's 7635 is the port that it's exposing. And we're off and running. So once again, we're going to inject that here using Lombok to provide our constructor for us. And let's get started. So for a request response model, we want to provide a single response. So a mono of type aircraft is what we'll be sending back. And we'll call this method request response. We're going to get a mono of something. I actually like to, if I don't have anything else that I necessarily need or want to do, I like to provide a timestamp so I can see what's coming in here. So, or when it's coming in, when the request is coming in. But again, it doesn't really matter what you provide. You can provide any kind of data coming in as a mono, as a request. I just like this. So we're going to use that. So I'm going to do on next. And when we get our timestamp in, I'm just going to print that out. But I like to, I don't necessarily recommend you do this for production logs, but I kind of like to see this in demos because it makes things very clear. So I just like to print a little emoji in there so we can see what's happening. And then I need to return a single value, right? And then allows me to do that. So I'm going to take my requester, my RSocket client, and I'm going to point to a route. And again, that's AC stream, upstream. And I'm going to provide data. Once again, I'm just going to provide an instant. Nope. Let's see, back up. Typing too fast. Instant dot now. And then I want to retrieve a flux. I know that we may get back 0 to N values. I don't really know how many. It depends on how many planes are flying over at that point in time. But I want to return just a single aircraft. So I'm just going to grab the first one. Next. All right. Now, since I'm going to be interacting upstream with an RSocket connection and downstream with an RSocket connection, when we disconnect, things can sometimes get a little bit messy in terms of this, kind of output in our logs. So I'm just going to kind of clean that out with an on error dropped, and we'll take the error, and I'm just going to just print something like connection closed. And there we go. Okay, so I'm going to go ahead and start that. And then while that's starting, I'm going to go over here and we will connect from our thing one. So requester dot route. And here, again, we've defined nothing. So I need to indicate the message mapping. We'll restart. And this we'll call request response. And we'll restart that so we actually have somebody listening on the other end. Request response. We're going to send data again, just going to send an instant. Nope, not an instantiation error. Now, and we'll retrieve a mono. We know that we'll be getting back a single value. And then once again, as I mentioned, we need to subscribe to that publisher. Publishers can be hot publishers. They can be sitting out there producing values, and you can kind of dive into the brook as it passes you. And in some cases, that makes a lot of sense. But in most cases, you don't want a publisher consuming resources and producing a lot of values that no one is asking for, no one's requesting, no one's subscribed to. So most publishers are they're cold publishers. So you need to subscribe to them before you can actually have any work done. So that's exactly what I'm going to do here. I'm going to take the aircraft and just print this out. And voila, let's get that started. Oh, we're in good shape. 17 minutes to go and like a million things to do. So a plan and not quite enough time. All right. So as you can see, it worked. Things never go wrong in live demos, right? But we sent over a timestamp, an instant, the current time. And we got back a single aircraft. And this is an American Airlines flight 765. Here's the national registration number, 510 Uniform Whiskey. And the flight number, of course, again, is very, usually it aligns with the call sign. The type is an Airbus 320 or 321. I'm not quite sure. Of the Boeings, they merge into some weird amalgam. I'm not sure if the Airbuses, they do that as well. But the current altitude, as you can see, is 33,975 feet. The heading is 260, so almost west, almost straight west, 453 knots, and it's got a position. So nice, very nice. Now let's take this a step further. So we have the request response covered. Now, again, I don't like copy pasting, but in the interest of time, I'm going to today. Please don't tell anyone. Of course, I'm glad this isn't being recorded. Kidding. Okay, so I'm going to change the message mapping to rec stream. I'm going to change the method name to rec stream so we don't have any conflicts. And I'm going to return a flux. Flux, if I can type. There we go. Instead of returning one with then, I'm going to return a publisher, which, well, take a publisher, return a flux, so then many, and then I can just remove the next and return everything we get back. And that's really it. Oh, I didn't, as you can see, this is the ugliness that you get if you don't go in and just clean that up. So I'm going to clean that up here as well. So hooks dot on error dropped, and we'll just grab that and we'll just say connection closed by client or from client to client. How about that? All right, that's good enough. We can debate semantics later. All right, so I'm going to, since I've got the server set up here, let's see, we'll just go down and we'll extend this a little bit, their example, and we'll do a request stream. And we want to, again, have a requester route that in this case to request stream. We'll provide data once again, the current timestamp will retrieve flux in this case, once again, a flux of type aircraft, and we'll subscribe. In this case, we will print this out and we'll change things up a little bit here. So airplane, and we'll grab one of these and another one of these just so we can see some differences, some distinctions between the two. And let's restart. So this is the second interaction model that our socket supports. We send one thing over, we get one thing back. And again, that one thing can be a collection of things, but I like to distinguish this because I think it makes it very much more clear. So we get back a flux of values, which come back again as they come in. So this could be 0 to n. And in this case, it's quite a significant number, right? So we have a lot coming in. And you can see that not all data fields are populated, like the call sign. If this is a non-commercial flight, it won't have a call sign like Southwest Airlines or Delta Airlines or Envoy or whatever. But the data is all there. In this case, maybe not so much here. That looks rather odd, but is what it is. All right, so the next model is the interaction model, is fire and forget. And in this case, we could do something like this, but it is a bit more idiomatic just to return a mono void, which interestingly is a value of no value, right? So it's a single non-value value. Anyway, we'll go with that. So fire and forget, it is more idiomatic in terms of the reactive approach. So fire and forget, we're going to receive a value. In this case, I'm going to up the stakes a little bit. We'll return a weather or receive a weather value. Now, in order to do that, we probably should define what a weather value is. So at data, class weather, and for weather is very important for pilots because it dictates if they can fly, or if they fly, where they fly, the altitude, what direction, if they need to go around storms and things like that. So I want to indicate we have when the observation was taken, of course, and then the observation itself. And once again, in the interest of time, sad, I'm going to copy paste that. So we'll return, we'll take our weather mono and do on next, and we'll grab the weather, read out the weather observation itself. And boy, that's right in the way. I'm going to scoot that over. And then we'll just print, well, let's put a cloud in there. We'll say that, the worst case. So weather, and then just return mono void, which is basically returning nothing, right? Once again, let's restart that. And then let's go over here. And I'm going to add our weather domain class here. So we'll also add that. And then let's go ahead and exercise our third interaction model, void. And this will be fire and forget. All right, requester dot route, and we'll point to, oh, I did not, once again, put a message mapping, fire and fire forget. Let's just keep it simple. All right. Fire forget, and let's send some data, right? So this, we need to, well, let's define a component. Let's define a weather generator. Sounds so official, right? If only, right? Okay, so what I want to do is create a list of observations that we can use here. Come on. There we go. And we'll call this our observation list of, and let's say we have skies clear, visibility, 10 statute miles. That's pretty good. That's a nice, nice observation. And then let's say we have broken at 080. So that's 8,000 feet and visibility of 7 statute miles. Okay. And then let's also say we have one more reading, which is just overcast at 200 feet, which is just terrible, right? Visibility 1/2 statute mile. And then it's US. That's how we roll, I guess. So, all right. And then we have, I like to insert some randomness into things because random is fun. And so we need to now have a generator. So generate, and let's generate some weather. All right, so return new weather. And I'm just going to do an instant now for a timestamp. And then let's grab an observation off the list using our random to grab our random value to grab the a position. So we'll just do the next int based on the size of the list. In this case, it's 3, but we could expand that and it would still work just the same. And then we're going to inject that here, the same as our socket requester, private final weather generator. We'll call this wxgen. So now we can just generate a value. So wxgen.generate. And then for fire and forget, we just send this value and then we subscribe. And once again, we don't get anything back, so we don't have to care about it. So let's go ahead and run this. Okay, we just sent over a value and nothing came back. So that's, as expected, right? So now just to really make things interesting, let's go ahead and kick this off with a bidirectional channel. We're going to return a flux of aircraft. We're going to call this, again, cleverly enough, channel. We're going to get a flux of weather coming in, weather flux, and let's process this. So we have our weather flux and do on subscribe. And let's just, here's our sub, and we'll just say subscribed. And then on next, so we'll grab the weather value and we'll just print that out. And of course, this time it's all sunny. So we'll grab that plus WX, and then let's switch things up. We'll switch the map. So in each value coming in from our weather flux, we will then request values from our current positions. So we'll send data instant.now, and then we'll retrieve a flux of aircraft. And that should be sufficient. Let's go ahead and run that and quickly go over here and we will request this from the other side. So grab that. Oh, what did I do here? Oh, of course. That should be much happier. All right. So unless I fat fingered that, which is possible, guess we'll find out. Nope, looks like it's good. So void channel requester.route. We're going to point this to channel send data. And once again, we'll use what? Well, actually, let's go back. We want to send a flux of values. So we'll use an interval of 1 per second. We're going to just create a pulse, a flux.interval. We'll map that pulse, that long value, to a generated value. And then we'll take that and we'll retrieve a flux of aircraft. And then we'll subscribe to that. And we'll take each aircraft and just print that out. And let's see. So let's grab this and let's grab that. And let's run this. So this is where things get really interesting with RSocket, because you see this dialogue that happens, and it's just a beautiful thing. It's over a multiplex connection. So you see, we're sending weather, we're getting back aircraft by the dozens or hundreds, and everything is working as you might expect. Now, very quickly, I want to do a native build on this. And in order to do this, I need to just do a couple of things. The big thing here, I'm going to kind of double up on time because we're short on time. So I'm going to provide a type hint. And so we have types. And the types that I want to include for domain classes are weather. Actually, I need to do this. Weather.class and aircraft.class. And I also want to have type names. I'm going to have to maximize that. So type names. So I'm going to grab my package name and bring that in dot weather. And once again, there we go. And dot aircraft. So this is a type hint that we are going to be using in our native application. So in order to do this, I can do this from the IDE, but I'm going to go ahead and kick this off here in the build. So let's see, desktop and thing 2. And let's see, so Maven, actually, I'll just do this, Maven Spring Boot build image. So let's go ahead and build a native image, right? I'm going to scoot that over here and just let that run. And while that's running, unless I've, again, forgotten something else, I'm going to go over here and we're going to take a quick look at Actuator. So let's pop this up. And of course, 8080 is where I've got the thing 1 running. So if we go to Actuator, did I not include Actuator here? Well, let's see, management, endpoints, web exposure, include star. Let's restart this. Oh, well, okay. So here is the interesting thing about Actuator. This is something I don't do this at home, folks, right? So don't do this in prod. This is insecure because what I did is open up everything, all endpoints, which you don't necessarily want to do in a production application, because you can go and check things like your environment. And in your environment, you can see a lot about your environment. This is exceedingly invaluable information for us, right, as developers and for the folks on the SRE side, but not very good to share with potential threats, right? The other thing that can do is if we go to config, let's see, what is, well, management dot what was it, endpoints, there we go. So it will tell you for each of the properties, which I only defined 1 at this point, but for each of the properties, it will tell you exactly where it's pulling it, because you can pull and load properties from anywhere, a number of different places, I should say, in your environment. In this case, we're getting this particular property from our application properties, line 1 and position 43, the value for it. And if you look there, position 43 is right there. So Actuator gives you some really good information. Now you can also, and this is something that's extremely useful, it's only been around for a few months now, but you can also provide startup information. So if you're wanting to get a little more information about your startup, that's kind of nice. So new Spring application, and let's just grab this. Yep, that'll work. And then we'll do an app dot set application startup. And I want to do a new buffering application startup. We'll set this to, let's say 2048 in terms of size. And then let's do an app dot run. And of course, we want to pass in our args. And we restart this, then this will expose a startup endpoint via Actuator that you can go and if not troubleshoot, you can certainly get some insights into your startup and the time it's taking for each of your startup things to occur. So let's see. Did I not refresh that? There we go. startup. So this tells you, it gives you some great insights. Now, Actuator is great to look at, right? So we can look through this manually, but it also is a great data feed for various different analysis tools and presentation tools in terms of graphs and perhaps some logic and AI that you can apply to this to get some very good insights into your application and how it's running. So let's see how we're doing on our build. Oh, I failed. What did I do here? So I must have, let me try that again. Oh, well, yeah, that would, let me stop this because Java-version, well, I am running Grail, so let's see. Or Graal, depending on your preference. So we'll let that run just a moment longer.
Yeah, we don't have much time left. Sorry, Mark.
Oh, well, it usually takes about 3 minutes to run. So yeah, we may run out of time on that. Yeah. Okay. Well, I'm not sure what I've done here, but yeah, somehow.
No worries. But we trust you that works. You know that sometimes we need to make sacrifices to the demo gods, and you probably forgot.
Yes. Oh well, that's why I actually have it still running over here. Oh man, I hate it when that happens. Okay, well, yeah. So I'll go ahead and start this building. We probably won't have time to finish it. I will go back to the slides while this is building because we should get a clean build out of it. And let's wrap up here. So yeah. So any resources. The best way to find resources that I share is just to follow me on Twitter because I kind of live on Twitter. As you know, if you follow me, and if you don't, why do you not follow me? But check me out on Twitter at MKHack. I do share all kinds of stuff, usually mostly interesting stuff, I think, mostly tech, a few just oddball things. Also check out Spring Boot Book on Twitter or at the link. I will post the repo and video coming along soon on some more of these things and extending these. But that I think is probably going to do us for now. And then let's go back here. And of course it's working now because I actually stopped the application running. So it will build properly. But any last minute questions here?
I don't think we do, but we really have to finish anyway. Sorry about that.
Well, let me just put it this way. When this finishes up in about 3.5 minutes, then I can run it. There are multiple ways to do this. You can do a local native build. I like to use cloud native build packs, and it does this, like I said, in about 3.5 minutes. It starts in about 0.08 seconds or 0.07 and 0.9, so less than 1/10 of a second. And it's just it's incredible the ease at which you can do this. If you've used other ways of building native images with Java, you will be blown away with how easy it is to make this happen with Spring Boot applications. So with that, I guess, since we're out of time, I bid you adieu. And if you have any questions, comments, or feedback, again, please do reach out to me on Twitter or email. Happy to discuss this at length. And Roberto, always a pleasure, my friend. Always a pleasure.
I mean, the pleasure is all ours. I mean, thank you so much for joining us today. I know that you're a busy man, so really grateful that you were able to take 1 hour to be here with us. So great present.
I'm just really happy to be here. I mean, you and I have talked for the last couple or 3 years about coming to JNation, and it's never worked until now. And of course,
well, I mean, now it's cheating, right? Because that's online. But we wanted you to be here in person.
But it works, and I'm just happy to be here. So hopefully next year, for reals. Yeah,
for real. Yeah, so great presentation as always. So thank you so much for joining, and we're gonna do a quick break to have our final session of the day and wrap up. Yeah.
Thanks all for coming, and hope to see you on Twitter and on the interwebs.
Thank you.
Thanks. Bye all.